I am going to do an example for homework. I think this is question 13 on the homework that's due. It's looking at the total cholesterol levels of a sample of men aged 35 to 44 are normally distributed with a mean of 210 milligrams per deciliter and a standard deviation of 38.8 milligrams per deciliter. And part A wants to know what percent of men have total cholesterol levels less than 213 milligrams per deciliter. So the cholesterol levels are going to follow a normal distribution. We know that the mean of the normal distribution, where it's centered, is going to be at 210. So I'm going to put that on there so we can sketch what that looks like. And then the standard deviation is 38.8. So if we go up one standard deviation, that's going to be at 248.8, 210 plus 38.8. And if we went down one standard deviation, we'd have an inflection point down here at, let's see, 210 minus 38.8, which is 171.2. So we've got something that looks kind of like this. Okay, and what we want to know is what percentage are below 213. So the portion that I'm interested in here is going to be this part going from 213, let me cut this off, and down below. So down here. This whole area down here. Doesn't want to fill that in for me. Let's see. This whole area, all the way down here, is the area that I'm interested in. This is corresponding to the percentage of men who are below 213, this whole area down below. Okay. Now, in order to find that area, what I'm going to need to do is I need to convert the 213, that's my cutoff over here. So remember that we are working with this cutoff of 213 here. Right? I need to convert this cutoff into a z-score because I'm going to use the z-scores of my lower limit, which is here negative infinity, and my upper limit of 213 to map this onto a standard normal distribution so that I can use that to find the proportion that would be below 213. So I take the z-score for 213. Remember that my z-score is equal to my my x value minus my mean divided by my standard deviation. So in this case, that gives me 213, that's a particular cutoff value that I'm interested in. I subtract off the mean of 210 and divide by my standard deviation of 38.8, and that gives me a z-score of 0.077. So what I'm interested in over here, I've got a mean of 0 on my z distribution. And I've got a cutoff on the z distribution of 0.77. What am I doing? Sorry, I don't have the right tools to do this really. I'm doing the best I can. 0.077, and I want this area down below that. And again, I want that whole area, and it doesn't want to show me how to color that all in, but there we go. Okay. Now to find this, I can use my normal CDF for the standard normal. So the percentage of the z values, standard normal values, that are less than 0.077, I can find using the normal CDF. I need to put in my lower limit. Here it's negative infinity, and I use minus 100,000 for my negative infinity. I put in a comma, and then I put in my upper limit of the z-score. So I put in 0.077. And if I put that into my calculator, second distribution down to the normal CDF, I put in negative 100,000, comma, 0.077. It gives me 0.5307. Which is equal to about 53.07%. You can see that here we had 53.08 was the answer that they gave, so a little rounding. Then to figure out, of the 256 men selected, how many we would expect to have a total cholesterol level greater than 268 milligrams per deciliter of blood, I would need to figure out the proportion of them that I expect to be greater than 268 milligrams per deciliter of blood. So to do that, let me get rid of what I've got here. Hold on 1 second, I'll pause while I... Okay, so now we want to know the proportion of the men who I expect to be greater than 268. So that corresponds up here. I've got my cutoff at 268. I want to know what proportion are above that. So that corresponds to the area under the curve above 268. So here I'm going to need to convert my lower and upper limits into z-scores so I can figure out the proportion I expect to be up there using the standard normal. So since my lower limit is 268, I need the z-score for that 268. So I take my z is going to be equal to the particular value, 268, minus the mean, which was 210, divided by the standard deviation, 38.8, and that gives me a z-score, say 268 minus 210, divided by 38.8 gives me a z-score of 1.49. My z-score for the upper end, since it's infinity, is still going to be infinity, so I don't need to calculate that. So then to figure out the proportion of my cholesterol levels that are going to be above 268, I can do that by figuring out the proportion of the standard normal curve that would be above 1.49. And the way that I do that is by using my normal CDF. Let me just make this wider. I'm going to put in my lower limit, which is going to be my z-score, 1.49. I'm going to put in my upper limit, which is going to be my infinity, which I'm using 100,000 for infinity. And that is going to give me, let's see, plug it in, distribution list, normal CDF. I put in 1.49, comma, 100,000. That gives me 0.0681. And then to figure out, I know that's the proportion of the 256 men that I expect to have total cholesterol levels greater than 268. So I need to take the total number of men, 256, multiply that by the proportion of them that I expect to be above 268.0681. And when I do that multiplication, I get 17.43. So if I'm rounding to the nearest integer, as we're looking at here, my nearest integer would be approximately 17. I hope that this helps. If you have any questions, please send me an email. Thanks.